Here's integrated 3. This is problem CL3-122. I'll try to do letter A and B. It wants me to graph this system of inequalities. So I see that they're both lines. So I'm just going to kind of ignore the inequality symbols and just graph them like y equals mx plus b. So this top line, b is going to be at 16. I've got this really small graph paper, so I can actually just count up to that 16 right there, or else you might have to count by twos or something. And then so b is 16, and that's 16 right there, and then the slope is 4, so I have to go up 4 over 1. Well, I ran out of room, so now I guess I'll go down 4 over 1. And I get the idea, so I'm going to just connect those. So that 4 is kind of a steep slope to have. So this, I see why this might be a problem for some people in class, because maybe you got out of the habit of graphing lines. I'm sure you've done this before, but anyway, here's a refresher. So this is b, the -4, so I'm going to put that as my y-intercept, this is my x-axis, and then I'm going to go, my slope is rise over run, so I'm going to go down 4 over 3, or down 4, right 3. So I go 1, 2, 3, 4, 1, 2, 3. And I can go the other way too. And luckily, I wasn't paying attention when I drew this line, but this actually is going to be a solid line. This one needs to be a dashed line, so I'm glad I didn't already draw the line. I'm going to try to draw it dashed because it's greater than rather than greater than equal to. So that's the difference. And same thing as if you're on a number line, you leave an open dot for if it's greater than, but a closed dot if it's greater than or equal to. Okay, so there's my 2 lines. And then basically, I think I heard one of you say this in class, if it's less than, you shade under it. And I trust that fully, and I am actually shade under it, but I'll also just test a point just to make sure. So I can shade under this one that has a slope of 4. So that means it would be like, I think I'm going to do my shading like all this direction, because the double shaded area is going to be our solution area. And this says greater than, so that means I have to shade above that line. So I'm going to shade above. And see where I have the double shading, like the cross hatching? That's my solution region. So basically I'm going to use, I think I've got a highlighter here. I'm going to highlight that. So it's, I don't know if you can tell, it's everything above the dotted line, yet below the solid line. So it's like, it's all the orange part. I tried to make it clear that I'm shading above the dotted line and below the solid line, and I can pick, I'm just going to pick a point that's in the solution region just to make sure that it works. So that's the origin, that's 0, 0. That should make both equations true. And so let's plug in 0. So this would be 0, less than or equal to, 4 times 0 is 0. Is 0 less than or equal to 16? Yes. And then I'm going to plug it in here. 0 greater than, that's going to become 0. Is 0 greater than -4? Yes. Would it be nice to check all the other regions? Because there's this region this region. There's other regions I could check, but I trust that when it's solved for y, if it says y is less than, shade below, y is greater than, shade above, and I did kind of check it. So that's how you do that one. It looks horrible. Now let's do, okay, that was 5 minutes, so we've got enough time to do 3-122b. It has these two. This is a parabola, and this one's a line. So I'm going to graph the line real quick because that seems like an easy thing to do. It has a slope of 2, or sorry, it has a y-intercept at 2, and a slope of 3/4. So it's going to go up 1, 2, 3, over 1, 2, 4, like that. And I see that it's going to be a solid line. So I'll just put that in there. Could I have done this algebraically with equal values? Sure, but they asked me to actually, let's see what they asked. They asked me to graph the system. I'm graphing it. So that's why I'm not bothering to use equal values or anything, in case you were wondering about that. So how do you like to graph your parabolas? I like to see if they factor. So, and I actually did it on some graph paper, because it's so nice if they factor. And this one actually does factor. There's my parabola right there. So I ask myself, what multiplies to make -3 and adds to make -2? Well, -3 times 1, we've gone over this in class a little bit, how to factor. So it factors out to x minus 3 times x plus 1. I don't want to go over the whole how you do this. There are other videos that show that, though. And then, so that gives me, I keep calling them test points. They're really their boundary points, but anyway, it gives me intercepts. So x is 3 and x is -1. Let's get the intercepts on there. So it says x was 1, 2, 3, and -1. So that gave me some intercepts, because I want to get the graph, because I can solve this just by looking at my graph, I think. So I know, so this is how I like to do it. I know you could do that little trick where you go -b over 2a. Actually, let's do that also. -2 over 2 is -1. So I could do it like that, or I can look and I know that my line of symmetry is where my vertex is, and it's exactly in between the two, it's in the very middle between the two intercepts. So I know that this right here is my line of symmetry, and it's also where my vertex is going to be, so that's the x-coordinate of the vertex. So the x-coordinate of the vertex is 1. Wait, how did I get -1? -b, oh, it's negative of -2, which is +2. See, if you use the formula, I messed up when I used the formula, but when I used the graph, I did a little better, but it's going to be +1. So I can find the y just by plugging in. So I'm going to plug in, let's do it on this paper. So I want to know what y is, so it says y equals x. Remember, x was 1. Is that -4? 1 minus 2. So I think y is -4. So 1, 2, 3, 4. And yeah, I'm not really super ooper duper. Oh, it's supposed to be a dotted line, I think, because of that. So don't worry, I can fix it. So if that happens to you, just make it look dotted or dashed, because it doesn't have, it's less than but not less than or equal to. So So any points on the actual graph are not solutions, so that's why we're making it a dotted or dashed graph. Okay, so I can just look at this and they just said to graph it. So I'm just going to use that same thing where I say less than is below. So I have to be below the parabola. So that's going to be like below the parabola. So basically on the outside of the parabola. And then less than, it's also below the line. So it's below the parabola and below the line. And I'm not going to use that highlighter again because that made it look way worse. So you can, I think you can see what the region is. It's not above the line, it's only below, it's below the line and below the parabola. Okay, so and I'm going to check that because yeah. See, they only asked you to graph it. They didn't ask you to find the exact points or anything, and those are fine for graphing, so you're good.